Welcome to the ASW Vault. In January 2022, Christien Rioux talked about how today's AppSec needs to move beyond its past and into a future of sandbox apps and decorated data. And he's someone who knows about AppSec's past. Also known as Dildog, he was a member of the 90s hacking group, Loft, and co-founded Veracode. This was also another episode where we talked about security as a software quality problem. In other words, just another type of bug. But we also talked about what's needed to make these particular types of bugs go extinct. The security industry could always improve the quality of its scanners, but real impact is going to come from devs creating more secure designs. Enjoy ASW 179 and stick around. New episodes are in the queue.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Christien Rioux, perhaps better known as Dildog, is one of the influential hackers from the formative era of 90s hackerspaces and the nascent InfoSec industry. He was a member of Loft, Cult of the Dead Cow, and co-founder of Veracode. Hello, Christien. Thank you for joining us.
Hey, Mike. How are things?
They're going quite well. So we are in the year of 2022. We're going to move beyond Log4j, perhaps, but
we hope.
Moved beyond. Yeah, exactly. We'll see. AppSec needs to do something different. AppSec needs to do something better, perhaps. I think you have a pretty informed and quite unique perspective on both the history of AppSec, as well as what AppSec looks like today. So, the idea of just broadening what we call AppSec should go beyond that cliche, I think. Unfortunately, cliche might be at this point of shifting left. What are some things that come to your mind when we talk about that?
Well, this whole shift left thing, we have a lot of language that we use in security and application security specifically. When we're talking about shifting left, we're really about making security and application security processes more attractive and palatable to developers. And these days, developer responsibilities are getting even more blurry. We have a trend toward cloud computing, to tend to cloud applications, and also the developer role is often moving toward having more responsibilities in production and real-time application security. So you've got the whole SRE role and being responsible for uptime as something that a lot of developers have to deal with these days. So over the last 20 years, AppSec has developed a sort of tooling-oriented mindset, and a lot of the tools have been justified by suggesting that the further left in the SDLC and the security development lifecycle that you implement security, the cheaper it will be. And I've heard that sales line. I've even used it to sell tooling as a service. And this kind of overlooks the fact that a lot of issues are going to escape that tooling. The fact is that none of them cover everything, and that really, things are going to go wrong in production that you couldn't have, predicted, and shifted left that far. So the reality is that no matter how hard you try, things are going to get into production that you didn't intend, and there's also going to be third-party stuff that you're not looking at, and there's all of the configuration-oriented stuff that developers don't really see because it's planned for, but configurations can change in production. And again, developers are kind of becoming more responsible for production code, and as a result, this sort of static analysis-oriented testing and point-in-time testing shifted all the way left is missing the mark a little bit. It's still an important thing to consider, and you want a defense in depth strategy when it comes to flaws. So I'm not saying don't scan. I'm just saying we need something that's a little deeper in the actual production space. So the operating system that these programs run on these days is the cloud. The cloud is really an operating system. And unlike other operating systems, I don't really think the cloud is sort of designed on purpose for security. When you look at mobile applications, there's a notion of a capability manifest. It says what permissions you have to click, say what you expect. Yeah, there's a notion of what expected behavior is when the applications are pushed into a mobile operating system. The permissions around cloud applications are far more loose. And there's no great way to define what expected behavior is for a cloud application. I'm thinking that much like how the mobile industry got better when the ecosystem got tighter in terms of security, that we're going to need that kind of a shift for cloud applications as well. Finding better ways to define what the proper behavior is for cloud applications. So.
Yeah,
it's funny. You have two parts there, right? You've got if you look at something like Amazon's IAM, there's all sorts of you can go quite granular on what you're doing on how you or your users are using the cloud. But then if you look at the application itself that you're developing, I mean, I just went through is trying to figure out what we're going to do for our back. There's 10 million different solutions, and then where do you put that choke? How do you choke? How do you not make something that's too confusing for your users? It's left for every single, maybe not developer, but developer team to try and figure out. And that's just, we're talking about authorization, not alone the rest of the pieces around that.
Yeah, IAM roles are kind of akin to like file system permissions or discretionary access control, that kind of stuff. So it's not what is my application expected to do. What does normal look like? It doesn't really peer into that. It's just sort of like putting some basic guardrails on how the OS is used around the app. So it was really about governing the use of some of those APIs. But that doesn't mean you couldn't legitimately use an API badly. It doesn't mean that you couldn't use the code as it was written to do something bad. A canonical example is a backend service that typically makes database calls and usually returns 100 rows from a call, from some query, and then at one time out of 6 months of use, suddenly it's returning 1 million rows. What does that look like? Why is it returning 1 million rows? Is that something a developer would be concerned about? Even if it's not somebody exfiltrating your entire customer database, it's of concern enough that it's a significant deviation. That it's the kind of thing that should probably have had a hold put on it so that an SRE can look at it, or at least to let people know that this thing is happening. But the logging analysis that we do these days without manually putting in tracing on this kind of stuff, and implementing something like an open tracing for your cloud app is bare minimum 20% CPU overhead and things like that. So a lot of people don't choose to put that kind of tracing in production. There needs to be mechanisms for monitoring the healthy behavior of an application and comparing against that baseline. I mean, we've seen that with desktop things like I'm a big fan of Bit9, but Bit9, for example, back in the day, Carbon Black, these things have policies for a local operating system, and there sort of needs to be at least some of that for the cloud. I'm currently working at a company called Lacework, and we're building stuff like that. And if you want to see more of what we're doing, you can go to lacework.com and see what we're trying to build in that space. I'm just new there. I'm just starting to help out, but I see the problem as a legitimate one. And tooling alone is not going to get you out of production oriented cloud problems.
Yeah, and you're hitting on some key aspects there. For one, just talking about SREs, hitting the idea of availability as part of that CIA triad, as well as even just quality, automation. How do we just do our job more easily at scale, to use potentially something that's become a bit of a cliche? But you were also talking about like mobile apps, and as operating systems, and mobile apps actually have a pretty decent sandboxing mechanism within them. Even browsers have become the client-side operating systems, if you will. They have pretty solid sandboxing, but the cloud, as you were just saying, doesn't. And those AWS IAM roles and all of the IAM roles, they're a lot more complex than the looking for a sticky bit or that chmod 777 files. So what are the ways beyond, you're starting to get into, I think, a little bit of that observability, what's going on within the cloud, but what are those aspects? Maybe we're not even shifting left because AppSec never even did it, but here's a practice that DevOps teams, developers should just be doing because it leads to better security.
Yeah. Well, in general, sandboxing, I think, is an underutilized technology. We could really use the ability to spin up application-level sandboxes for every piece of a cloud application. Developers aren't going to want to put this in their app by themselves. Frankly, can't ask developers to do anything differently. Whatever solution comes along for sandboxing cloud applications basically has to be zero touch. Developers don't want to add anything to the CI pipeline, though they might be willing to one time just to get something set up so that it, fire and forget it. But if it requires constant, wrangling, lots of false positives, interruptions, it's going to get rejected. And, people, will just assume and accept the risk rather than wasting their own personal time. So, the question is, where do you put this stuff? Do you put it in what layer? If you're not going to wrap the app itself, do you put it in Kubernetes? I mean, you're already asking Kubernetes to do a lot. It's already doing a lot. A lot of people don't even know what it's doing. And you have systems that are responsible for orchestrating applications, but they don't. When they do that, you're lowering the visibility. Kubernetes makes it harder to know what exactly is going on at any one time. But it's not Kubernetes specific. It's any kind of orchestration system, any kind of automatic scaling, load balancing, proxying, all of that stuff makes it harder to determine what the state was of a cloud app at any one time. So if something did go wrong, and let's say you did get a notice, by the time you go and look at the app again and check the logs again, the instances might be gone, or things have shifted around on you. So really, unless you have the ability to record the state of a cloud app and keep a history of what it looked like at a particular time, you're not going to be able to correlate the findings that you've got, the logs, the reports, with what the app looked like at the time that things were going south. So you really do need some kind of cloud in-flight recording going on. And I think that should be kind of a bare minimum thing that everybody that does a big cloud production system, is looking at. They need to be recording the state of the app, the network connections, the what talks to what APIs get used, what errors are coming out of that. Because once you've done all that data collection, you can look at it and mine it for anomalies. And even if you didn't catch some application level thing, it's going to have effects down the stack to the network. So nobody's going to just hack one instance of your app without doing some other exfiltration or making extra network connections or writing to the file system in a weird way to get persistence on it. So you're basically looking for indicators of compromise in real time by recording the state of the app and then comparing it against that baseline. So I mean, that kind of thing needs to exist. As far as sandboxing goes, once you've got that baseline, the sandbox is kind of automatic. It's anything that doesn't fit, and without having some exception given to processes that behave differently. And you could be looking at changing the the sandbox when you push new code to production. Because if you're going to be adding a new feature or something, maybe it will need different network connections. But during that sort of continuous deployment cycle, there's going to be windows where you expect things to be different, and then there's going to be this sort of steady state where really, if anything goes other than what you expect, somebody's doing something funny and it needs to be looked at.
Yeah, so this type of thing. Briefly, this type of thing. My last company, we were working on this, and we started getting a lot of questions from customers. So I'm curious your thoughts here. And one of them is around only certain applications this will work for, at least in my case, right? So we were getting low-level syscalls out of a container, and then doing modeling around that, being able to fingerprint the application. So if you've got an application which is you've forklifted something in and it's doing 10 million different things depending on the time of day or month or year, suddenly your baseline becomes very difficult there. So I'm sort of curious to hear your thoughts around that. And then the same type of thing, at least from my experience, it depends on, do you do that baselining in prod or in QA? And then if you go do it in QA, it comes down to how good your tests are. So I'd love to hear some of your thoughts around the little more the details around that type of thing, if you have any.
Right. Well, you can do it in both. If you're looking at QA, you really can't compare it to production. But you can try doing things in QA, like adding automated fuzzing and recording baselines and comparing against one version of things versus if this is really extension of testing. I mean, security in and of itself sort of is an extension of just software quality in general. So the quality profiling and quality testing and automated testing people do, any good security tool just sort of fits into that mindset. In terms of monitoring, you're really looking at like using a rasp style monitoring in QA at that point. What we're really talking about here is sort of a rasp type setup for the cloud. But it needs to be something that doesn't involve like spinning up extra instances and getting in the way of the architecture of the application. Once you start changing the app for security, people are going to reject it. So the question is, how do you get in there and monitor applications in such a way that it doesn't change the function of the app? You have that quantum problem.
I think one of the things that you spoke on you mentioned earlier too is I think bugs that are going to escape to production or bugs are going to happen, and really a lot of this conversation you've been focusing on software security as a quality problem, talking about the SREs, talking about basic visibility, and not really talking about particular vulns. And I suspect that's actually pretty purposeful because maybe one of the things of broadening AppSec, or one of the ways that AppSec was shifting left, is saying in an incorrect manner maybe, was just go fix these bugs earlier, go find these bugs earlier. What's you're de-emphasizing the bugs there. What's kind of on your mind as you're thinking about that is teams should be doing better with building the observability or and other types of things?
Yeah, I think that the lack of reasonable observability tools that are we're looking at things that will tell you if you got hacked a few days after you actually got hacked. I mean, the world of observability needs to improve. With regard to individual flaws, things like static analyzers and dynamic analyzers, those are niche things that find 0-day type, $1 million bugs, that kind of stuff. You can afford to spend a lot of time looking for those. The ones that like the log4j stuff, that's been out there since 2016. I mean, it was reported at Black Hat how to exploit this stuff, and they even pointed to log4j as a great example of how to do it. It's been 4 years, and only recently, and it's we push that stuff to production despite all of the scanners that we've written, despite all of the AppSec and static analysis tooling and dynamic analysis tooling. Nobody just noticed, oh, by the way, there's millions of this thing everywhere. If that can happen, it's already happened again with something else. So the question is, how would you detect that compromise sooner and prevent it from, becoming a problem? I mean, we had a chance to catch stuff like Log4j. We had a chance. Static analysis, dynamic analysis, all of the developer tooling in the world, all the security products in the world. The only thing that made a difference was, some people calling it out the right way. And even the research is old. So, it's sort of a shame that people have spent a lot of time writing tooling and are really only finding very easy, low-hanging fruit type vulnerabilities. Anything that's even more complicated than a single Java jar file in terms of like complexity.
Right.
And we're not finding that stuff,
No, and maybe, the world fortunately didn't immediately come to the end at the end of 2021 because of Log4j.
Sure.
Lots of teams were really busy, that lots of people had to invest time to address it. But you were also, the way you were talking about cloud sandboxing, that's got to be a way to say, sure, bugs like Log4j are going to happen because the tools are frankly missing them, but maybe the sky doesn't have to fall if we have things sandbox, like we're blocking egress filters, and maybe we're blocking network traffic but not DNS.
The people the people that I know that were the most well protected against Log4j specifically had manually implemented some egress controls, like they had outbound proxies for their application. None of the instances in their applications were able to reach out to the internet without going through a proxy choke point, and that proxy choke point knows exactly what sites the app normally contacts. Okay, let's say it needs to do some kind of, API access to something. There's a list of things that the app touches. All of those Log4j exploits out there would have needed to have both a proxy key, which would have been app specific and, that made it difficult to write the exploit for, but also, only be egressing out to places that were in the allowed list. So not only would they notice the vulnerability, they would notice the weird behavior. It also would have just completely protected the application. It's the kind of thing that, maybe, an extremely advanced attacker would have been able to write some kind of payload that got downloaded and then acted completely internally. But they would have had to have a lot of very specific knowledge of the application to make that exploit work, and they would only get one shot. It would have to be like a disgruntled employee or former employee, one of these things, where they had special white box knowledge. Joe Schmo in ransomware farm out there is not going to be the one that even if they did pop some instance, they just down it and turn it back on again, and the people are used to the cloud just crapping out. 80% of your stuff dying here and there, USES1 going down, whatever, apps is still there. They keep running. So, I mean, we've gotten to the point where you monitor things, and if they stop working, you reboot them, and it's like
exactly.
Attacking these things just becomes very difficult if those simple things are in place. So, between the things like egress filtering, proxying, and a better sandboxing model eventually, it's going to be very hard to exploit things that do make it into production. And I think raising the bar on the attacker is probably the long overdue for cloud apps.
So that's interesting. In the spirit of raising the bar, now Log4j is a good example of a pretty bad issue that wasn't for once a memory safety issue. Still hit Java, and you still have a lot of teams that are moving towards popular modern languages like Golang or Rust. Again, those are attacking or targeting memory safety, having issues, getting rid of attack classes. Do you see lots of successful adoption like that, or do you see what would you call attention to in terms of here's some attack classes that we could just do better on, or maybe even it's just a matter of default configurations need to be more secure?
Yeah, you'll notice that most of the actual improvements in application security have come from the languages. C obviously made it really easy to do the wrong thing. C++ didn't do much better. Java still has issues. The languages like Go and Rust are eliminating classes of flaws, or at least making it harder. Rust is closer to the metal than Go, but there's still a lot of Rust crates that link in C, because it's often seen as a replacement for C++ in the same way that Go is seen as a replacement for Java. I'm afraid that some of the guarantees of Rust are being poisoned a little bit by their inclusion of unsafe code in a lot of places. People are being a little less careful with it than I think they should. That's besides the point. I think it's a great advancement because it gives people the tools and it makes the tools the default. It doesn't make screwing yourself the default, which has been the case with a lot of previous languages where you have to specifically think about security all the time. If you want to make Rust insecure, you really have to go out of your way to do it. The third-party code problem definitely makes it easier to screw yourself accidentally. And it should be, that's the kind of thing that we can be doing a better job just reporting on third-party code. We could be saying, I'd like when I go to crates.io, I'd like to be able to look at a Rust crate and determine whether or not it or any of its dependent crates uses unsafe code.
Yep.
And there are cargo checks that you can do for that. And there's cargo plugins that you can use to check for that stuff. But I'd like to be able to, like, when I'm making it as architectural decision to include somebody else's code, I'd like to know a little bit more about it. The opportunity to implement some of the software bill of materials stuff on these crate repositories and Go repositories, the bill of materials stuff needs to be way better for those things, so we get a better idea of what we're actually building in. As far as Rust goes, the other things that it's protecting you from are race conditions. It does a really great job of synchronization across threads and managing resources that might otherwise result in race conditions. But really no languages today package handling requirements for data along with the data itself very easily. Data is really naked. When you pull in a GIND URL out of some log4j thing, there's nothing saying that the insecure user input can't commingle with stuff that needs to be secure. A lot of the static analysis that we do is code that does taint tracking and tries to make a judgment call about whether or not data has been handled correctly. And that's the kind of thing that should make it into some language. I'd say Rust is a candidate because of its strong typing system. The ability to say this data that comes in from this API call should be handled in a certain way before going out this output. That kind of programming tool, like being able to taint arbitrary, variables and classes and determine, like, be able to say this thing's a credit card number. There's no way it should be written to disk without it being encrypted or something like that, or a password needs to be hashed before being written to disk. Language level support for that kind of thing, where it's the default, where you can specify things like personally identifiable information or things that need a certain kind of handling. Languages really need to support that as a first-class thing, because that's what these security scanners are doing. They're exercising the properties of data handling. And if we want to obviate the need for a Veracode or a dynamic scanner, the language needs to support doing it the right way and making it harder to screw up data handling.
Yeah, so I think go ahead, John.
You answered this question in the last few words, but I'm going to ask it anyways because I want to see if we can dig a little deeper. As you were talking through there, yes, we need languages to have better support for some of these concepts, the data concepts. I was going to ask, could you see, like in either Go or Rust, having a structure, basically having third-party data types? So have, like, here's a credit card struct that when you bring data into it, you have like your getters and setters on it. It does all those checks automatically. Do you think something like that could have a chance of, I'll say, helping people? Or do you actually think it really needs to be built into the language itself as that first-class citizen?
I think the language needs a few enhancements that I think are actually being worked on already. I'm not a complete Rust expert, and I'm not, I'm definitely not steering committee level, but I've been keeping up with the changes in the language. And one of the things that needs to be implemented for a library like this to exist as a third-party thing is the notion of negative traits. Being able to say that a trait is unimplemented for a particular structure or a particular type. So basically, you'd be able to create third-party negative traits on other people's types. Once you can do that, then you can import something that adds negative traits to other aspects of the the standard library around a Rust program. That would allow you to say at compile time, if you're treating some data the wrong way, that it won't compile. At runtime, you can simulate it with taint. Taint tracking at runtime is sort of like positive negative trait propagation at compile time. It's a little complicated, but basically you want to catch things at compile time if you can. And the whole Rust ecosystem has this whole trait analysis type propagation thing that it does as part of its verification mechanism for the biochecker and everything else. There's this whole type validity checking that it does. And if we could leverage that, once they get the negative trait stuff built, one could build a crate that said, basically, nothing can go out, this hole, or, written to disk a certain way without having gone through certain things. If it, some data is got a trait that says must be secure and is written directly to disk without having passed through something that secures it, then, it would be, at fault, there would be a compiler fault. So that's the kind of level that we need here. And, the language support can get there. It's just not there yet, but I think generally we're working on it. In a couple of years, I think Rust will be a great candidate for the first language that can actually do that kind of verification at compile time.
That's very cool, and it ties into the theme that's emerging here is observability broadly at the cloud that you were talking about, but then observability into dependencies, into code, as well as then, as you're rightly pointing out, when flaws happen, exploits happen, nobody wants just to exploit the software, to be successful. They want to exploit the data behind it, or that's where the money is, that's where the access is. Nobody cares about getting root necessarily. They want that data, which, as you're describing, if it's well decorated in these ways, tainted, you can figure out when it's protected and when it's not.
It allows us to expressively control how data is handled, and that we lack that today generally. Or it has to be manually implemented every single time, and people get it wrong. So.
No, indeed. Well, Christien, your Twitter bio includes the phrase, be kind, do something. You've clearly been doing many, many interesting things for quite a while. And one of the hopefully interesting was joining us. So I just want to say thank you for taking the time to chat with us now. And also ask you, is there something we should be keeping an eye out for as you're busy doing something in 2022?
Yeah, sure. I've started to do some work in the social media space. I'm starting to think about decentralizing social media and what it would mean. There's a lot of talk about Web 3.0 and blockchain this, and people building new social networks and communication systems for anonymous chat over some kind of distributed app framework. I caution people to look into how those apps are being written. The idea of decentralizing social media is really important. I think we've come to a position where the algorithm is making calls about people's content that is really bad. There's a lot of complaints I could do about centralization, but I have just as many complaints now about how decentralization is happening. And I'm looking to write some code, put some stuff out there that does decentralize social media in a different way, and hopefully. Without incurring some of the profit motive that I'm seeing from a lot of the companies that are doing this. You've got, a lot of crypto people, and by crypto, I mean cryptocurrency, that are implementing these things because, they've got freedom, something or other, you don't want to be censored, got kicked off of Twitter for a bunch of Trump shit, whatever. It's the kind of thing that we have to implement, but we have to think about it very carefully, because the problems that social media has today caused its centralization. Web 1.0 was decentralized, but then you started adding advertisements, and then you started putting profit motives in everything. And suddenly people became the product. There's a reason your Facebook is free. We need to get the money out of social media. And to do that, you can't base it on a cryptocurrency. It's just a different kind of profit motive, and it's going to different people. So we're going to be working on ways to, toss that up a little bit, show people that your participation online doesn't necessarily require you being the product.
Thank you for that. We'll keep an eye out for that. And maybe next time, speaking of people as the product, we'll talk a little bit about Soylent Green and what that meant. Just want to say
let's not get there. Let's not get there.
Thanks again, Christien, for joining us. And for everybody who would like to follow more about what he's been doing, follow him on the current social media centralized platform of Twitter @DillDog.